simplify. So that when you think you're done with the problem, always check up on these 3 requirements. Are there any perfect squares left in the radicand? Are there any fractions in the radicand? Or do you have any radicals in the denominator? And if you say yes to any of those, you're not done. Now, you might be wondering though, what happens if we get something like this, and we take the square root, we have the square root of a fraction, we break it up using the quotient property, and then in the end, you just end up with a radicand in the denominator. Well, now what? Because it says we're not allowed to. So the question is, what do we do when we're stuck with a radical in the denominator? We've done everything we could do. There's nothing else you can take the square root of, nothing else you can simplify. And now, this is what we call rationalizing the denominator. When you have a radical left in the denominator and you don't want it there, we have to do something called rationalizing the denominator. And what rationalize the denominator means get rid of that radical. That's what that means. And so you might be wondering, well, how are we going to get rid of the radical? Well, think about it. If I had the square root of 5, the only way I can make this not be a square root of 5 anymore and come out of the radical is if I multiply it by exactly itself. Because look what happens. Square root of 5 times square root of 5, what do I get?
25.
Square root of 25, which is what? 5. Okay, let's try another one. Square root of, because that might have just been a coincidence. Square root of 6 times square root of 6, what do I get?
36.
Square root of 36, which is? 6. Okay, that's weird. Square root of 12 times square root of 12, what do I get?
Square root of 144.
Which is? Do you think that's a coincidence?
No.
What pattern do you see?
It's going to end up being the same number.
It's going to end up being the same number that you started with, except for what's different about it?
There's no
There's no radical. It ends up being the same number, there's just no radical sign. And the reason for that is because square root of 5 times square root of 5 means square root of 5 squared. Well, a squared and a square root are opposites, so those cancel each other out. So you're just left with that number. So if you wanted to get rid of that square root of 3 on the bottom there, how would you do it?
We multiply 3 times square root of 3 and then get square root of 3.
You'd multiply it by the square root of 3. But am I allowed to just multiply a fraction by whatever I feel like? No, that's not allowed. But am I allowed to multiply anything by a form of 1?
Yeah.
Because what's anything times 1?
Itself.
Itself, so I'm not changing the value. So watch. If I multiply the top and the bottom by the radical, whatever radical is down here, what's going to happen is the bottom is going to come out of the radical sign. So we just saw what happened over there. And then I'm multiplying it by a form of 1 because anything over itself is 1. So I'm multiplying it by a form of 1, so I'm not changing the value. So you're allowed to do this, and this process right here, this step right here, is called rationalizing the denominator. So let's see what happened. 2 times root 3 is just 2 root 3. Root 3 times root 3 is root 9, which is just 3. So we end up here, 2 root 3 over 9, 2 root 3 over 3. This process here is called rationalizing the denominator. Please make a note of that in your notes. Yes?
Can we cancel out the 2 3s or no?
Say that again?
Can we cancel out the 2 3s or no?
Good question. Can we cancel out the square root of 3 over 3?
No.
Why not?
One is a square root of
1 is a square root. Now put square root of 3 in your calculator. You're going to get 1 point something. Is 1 point something the same thing as 3? No. So the square root of a number is not the same thing as that number. So don't get fooled. Although they look the same, it's like Snickers and poop. They're not the same thing. You can't cancel them out. Okay? All right. Take a quick note on that, and then we'll try 3 example problems, and we will be done with notes, guys. Rationalizing the denominator. Rationalizing? That's it? That's not what it's called. It's called rationalizing what? Yeah, right. You're gonna forget. Oh, yeah.
Seriously,
Right, and then, right, what is it? Because right now, it's fresh, but next year, after the summer of not, the winter not doing it, you're gonna forget. So what's the purpose of rationalizing the denominator? Why do we do it?
So that we don't get the radicals that we don't
So we don't have a radical in the denominator. Why don't we want a radical in the denominator? Is it simplified all the way if we still have a radical in the denominator? No. Okay, so what it means to be simplified, we have to make sure we meet those three requirements. All right, guys, last but not least, let's take a look at these three. Please try these out on your own. Simplify it. If you end up with a radical in the denominator, you need to rationalize the denominator. Make sure all three requirements to be simplified are met before you stop the problem. Last three, guys. Why? Are square root of 2 or square root of 3 either are perfect squares? This is as simple as it gets. But 3 over 6, and you reduce that function. Do it. 3 over 6, and you reduce that fraction. So do it. Okay, you're good, but now you need to rationalize the denominator because you have a radical in the denominator. Let's see. So you got that and that. This is a 3, this is square root of 3, but it's the same thing. So they don't cancel. Yeah? How did you get from here? Okay, oh, I see you divided both of those.
Yeah.
And now?
Yeah, I don't.
So now, and we can split it up to 3 over root 2, since we can't reduce either one if we want. And it would be done, except you have a radical in the denominator. So you need to do what? Or just rationalize the number. So you divided both of these by 3.
No, it is 12. My bad. I remember.
Okay, anyway, keep going, that's just fine. So now rationalize the denominator. How do we do that? 3 what you just wrote. And look at what you just did.
Wait, what did you get to the
Okay, how are we doing?
2x root 12x over 12, right?
Why not? Indeed. Chia. You got it?
We got the second one.
second one?
Okay, great. Yes.
Wouldn't 3 then still be?
It's still the
It's
square root.
allowed, it's allowed to be this.
Right, exactly, yeah. So here, when you rationalize, show me your step of ration. Oh, you're here, you're doing it right here. Okay, sorry, keep going.
It's y through root 2.
Okay, well, you can't finish with the square root of the denominator.
It doesn't have a square root. It's not a perfect square.
Right.
So you have y cubed root 2 over
Just put down the square root.
root w.
W.
You have to
And then you can break
you
that
have
up.
y cubed root 2 w over w.
What'd you get from 3? How'd you get that? All right,
You just
wait,
You
what?
take the square root, but you can't write the square root. What do you do? So it's just y, it's y. You just multiply by w.
Okay,
Oh,
can I help?
yeah, yeah.
You get 2w over w. Chia.
Okay, why don't you, since this is already in a fraction, why don't you reduce these ones?
The last one.
Reduce those numbers inside the fraction first. Who's done with all three? Okay, we'll just take another 30 seconds or so and see if you can complete it, and then we're gonna go over each one. Feeling good about all three? How are you guys doing? You guys compare with each other and with Louise? You're all in agreement? That's a good sign. You stepped in?
No. Drumming.
Close.
Air drumming.
Yeah.
X3, one X outside of one.
And also here,
I need a joke.
Alright guys, let's take a look and see how this went. So starting with this first one, what's the first thing you did?
We simplify.
Okay, how many of you simplified this fraction first? How many of you broke it up into two separate radicals first? Either way is going to work out, you're going to get the same answer. So let's see what happens. If I simplified these first, what can go into both? 3 over 2, so we end up with 3 over 2 inside the radical. Now what can I do from here? Break it up to this and this. Now, the problem is, this would be done, except I'm not allowed to have a fraction in the radical, so that's why I broke it up. But then I'm not allowed to have a radical in the denominator, so what do I have to do at this point? Multiply by root 2 over root 2. Why root 2?
Is that what made the denominator square?
Okay, that's what's going to make the radical denominator go away. What do we call this process?
Rationalizing the
Rationalize the denominator. On the top, root 3 times root 2, what do we end up with? And on the bottom, root 2 times root 2, root 4, which is? 2. So this is the correct answer, guys. If you did it this way or if you did it the other way, you should have gotten the same thing. Raise your hand. If you got it right, sorry. I didn't finish my sentence. Okay, if you did it the other way and you split it up first, take a look at what would happen. We would get this, and then we would rationalize, and then we would get this, and then what would we do at this point? You would simplify the number. If two numbers are outside of the radical, they can be simplified, and if two numbers are inside the radical, they can be simplified. You just can't simplify something inside with outside, okay? Or vice versa. So now these will reduce to 1 over 2, which you end up getting the same thing. Okay, question? Now who got it right? Much better. Let's take a look at the second. The second one. What would you do first? Maria?
Simplify the fraction.
Simplify the fraction. Since they're both inside the radical, they can be simplified. What do we get when we reduce them?
1x bar 3 and 3.
And 3 down here. So I'm going to rewrite this as a big radical. We get 1x to the third, and 1, we don't need to write the 1, over 3. And now what should we do at this point?
Multiply.
Even before that.
No, you like
Split it up. Okay, now, square root of x cubed. How can I split that up?
x squared
Good.
and
And we have this. What's the square root of x squared?
x.
So on the top I have this, and on the bottom I have this. Am I done?
No.
What do I need to do?
Rationalize the denominator.
Thank you for using the vocab. Rationalize the denominator. So on the top, anything that's inside radicals, they stay together. Anything outside stays outside, and the bottom, there's nothing you can reduce. Raise your hand if you got the second one right. Okay, fewer people. See what mistakes you made and what questions you have.
What do you multiply by 3?
I'm multiplying by the square root of 3 here. That's called rationalizing the denominator. The reason why I'm doing that is to get rid of the square root sign in the denominator, because it's not simplified until you get rid of it. Yeah.
So when you have two things next to each other that are in a radical
Uh-huh.
group, you
multiply them together.
This means multiplication. This is the opposite of product property. Instead of splitting them up, we can put them back together in one radical sign.
Basically,
Yeah.
can you redo the problem except without, like, simplifying 8 and 24?
Sure, you wanna just split it up from the beginning?
Yeah.
So let's do that. So if I split it up from the beginning, I get this over this, and then I get this. And on the bottom I have this. Now on the top, I can split up the root 8, and I'll do that up here so we can have some room. I split that up to this. Okay, that's the root 8. And then the root x cubed, I can split up to this, which I get this. And when I put those two back together, I have the 2 and the x in front, and then the 2 and the x inside. So that's the top, 2x, root 2x. And on the bottom, square root of 24, I can break up to this, and then this.
Okay.
Good? So now I have this on the bottom. At this point, I have options. First, I'm gonna just get rid of this because that's quick and easy. And then I could put these back together first and simplify the fraction, or I can just rationalize the denominator. I'll just rationalize it at this point. Okay? When I rationalize that, on the top, I'm gonna stick with x outside, and on the inside I get 12x, and on the bottom I have 6. Okay? And at this point,
No, you put it.
did I forget something?
You know, you finish 12, don't you?
Yes, thank you. And then at this point, I have the 12 still inside, which I need to reduce the square root of 12. So I split that up to this, and I get this. So now, this turned into, the 2 is on the outside with the x, so that's 2x on the outside. Inside, I get root 3x over 6, and now I can reduce those as well to 1 and 3.
Yeah, we were one step, we missed it.
Okay. All right, last one, guys. You guys have been awesome. Take a look at the last one. Is there anything I can do from the beginning to simplify? No, so what should I do?
Just put those.
Split them up. Okay? When I split this guy up, let me do the top separately, so I have this and this over this. Y to the 6, what's the square root of y to the 6? Y to the third, good, you're getting good at that. Y to the third comes out in front, square root of 2 stays inside, and square root of w. Am I done?
No.
What do I need to do?
Multiply by root of.
Rationalize the denominator.
Thank you. Rationalize the denominator, which means multiply top and bottom by square root of w. So on the top, I'm left with y cubed root 2w over w. Make sure you have a good last one. Guys, I am so proud of you. We are going to do a basketball activity now. You need to get in a group of either you need 4 people in your group. One group will have 3 people. Please quickly read step 1 and follow the instructions. Yeah. Quick, quick, quick. So, you should be getting into groups of 4, one group of 3. Who wants to be a group of 3? Okay, you 2 with who? You 3 are a group of 3, everyone else should be in a group of 4. Okay, so Jess, Cami through Jess, that's one group, get together. Come up with a team name super quick, and come up with who's gonna play each role. And you guys are gonna have one person playing 2 roles, okay? Quickly, 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 assign your roles, fill in that first box.
I will be the scorekeeper.
Lakers.
Be the ball. Be the ball, so I
Okay, fill it in.
Announcer.
Fill in your team name,
Right, I'm the
the
announcer.
scorekeeper, the announcer, the baller, the shot caller. Who is who?
Yeah.
Who did all of
They're right here. And I guess shot caller over here.
County is.
We
Yeah,
are,
shot caller. Yeah, getting smacked.
Okay, ladies and gentlemen, now that you've picked your roles and your team names, please listen carefully to instructions. This activity, I call it Got Hops. Why? Because you are going to be using mathematics and rationalizing the denominator, which is what we just learned, to calculate your hang time. Who knows what hang time is?
How long you staying there?
How long you stay there? Who's seen or watched on TV or been to a professional basketball game? Okay, some of you. Now, when we're watching basketball, a lot of the professional players, they don't just like shoot from the ground. They usually jump up in the air. They're usually hanging in the air for a split second or so. They release the ball, and then they come back to the ground. Yeah? Can anyone visualize that right now, what that looks like? You have to be really strong to be able to do that. I've been trying to do that for years, and I still am not that successful at it. But you'll see people who are really good at basketball and are very strong can do that. And so you guys are going to be calculating your hang time, and it requires rationalizing the denominator. So we're going to practice this skill. In just a moment, you're going to be dismissed to go outside. You'll notice there's a piece of green paper out there. Out there, take a look. Each person has a different role in this activity. So the baller is going to stand as straight as they can, stretch their arms up, and they're going to make a mark on the paper. And then they're going to take one jump as high as they can. Okay, it's not a running jump. It's not starting back and running. It's just one jump as high as you can, and then you're going to make a new mark on the paper. We're then going to bring the paper down after all three teams have gone, and we're going to measure the distance between there. Okay, that's what you're going to fill in that bottom box. Turn your page around. Step 3, you're going to convert the number of inches jumped into feet. And then step 4, we're going to use the hang time formula to calculate the baller's hang time. So we can use this formula, which is the height equals 4t squared, t being the hang time in seconds. You're going to put the difference of the height that they jumped into that box and use algebra to calculate hang time for that particular individual. Does that make sense? At the end, you're going to keep it as a simplified radical expression. So do not turn it into a decimal until step 6 so that it makes sense to you. So we can then see in our competition who out of our different teams have won. So I want you to just take a quick minute more to read through the instructions so you're very clear about it. And then in about 1 minute, I'm going to dismiss you to come outside, and then we're going to actually watch the competition. Okay, go ahead. Read all the steps so you know you're clear on what your role is. And shot caller, please grab a ruler as you're coming out. You know where the rulers are in the student station.
Just recently, I mean, it wasn't directly related to it, but this housing area up on the hill, this is low-income government housing.
So, we're going to go outside right now. If you're a baller, you're going to come close to the paper. If you're not, if you're the shot caller, you need to grab a ruler. And then everyone else, go ahead and take a seat, and we're going to take turns to see what I'm intending. So everybody come on out. Ooh, it's bright out here.
Very.
Come on out. Ballers, get ready. Stretch those limbs out.
I'll probably like touch the top of it.
Okay, let's talk about it after class, yeah?
So maybe can I quickly go over those?
Quick.
I
Okay,
can like jump over
you
it.
think you can? Show me. Wow. Okay, you go grab a pencil then, we're gonna have to erase it off the wall.
I didn't.
Because I couldn't get higher than that.
Wait, what?
Go grab a pencil from inside. Okay, who are our other ballers? Seba and Dylan. Great. Dylan, you'll be red. Seba, you'll be blue. And Aiden will be pencil. Guys, come, ballers, come forward. Ballers, come forward. Okay, go ahead and make your, you're gonna stand and make a mark as high as you can.
Estamos cuatro, cuatro,
Perfect.
This, maybe we have to go this way with this cart.
Okay.
Tú primero, porque you know.
All right. So let's go ahead and start with our first baller. We'll start with Dylan. Dylan, the objective, I hope you guys don't forget about that paper. You think you will? Okay, let's retake that paper then. Sorry guys, I'm not as tall as you guys. Excuse me, sweetie. Seba, come. Seba, can you take the paper off and then re-tape it? Re-tape it as high as you can. Good, and there's another tape there on the side. Okay, great.
Wait, now
Much
we have
better.
to redo the thing.
Oh yeah, you guys need to redo your marks. Oh, that's confusing. Okay.
Just turn it around. Let's do the lower one. That lower.
Oh no, you're gonna be blue. Here, we'll give you this. This one. Use it. Okay. All right. All right, fellas. Who would like to jump first?
So I just jump and then like.
As high as you can and make your mark. Okay? All right, very nice. That's the black team.
Tiki. Woo!
Right. Okay.
That's not straight.
Okay, do it again and do it more straight. And we'll do the highest point. Oh, even higher. Okay?
Okay, this isn't like.
Try one more
There's a
time.
little spot there.
Try one more time. Try one more time.
It's a bad marker.
There you go. Okay, Aiden, we'll give you one more jump since we gave the other boys more than one jump. Okay. Now remember, it's the difference. We're finding the height is the difference. So can you? Okay, you didn't put something. Oh, lovely. Okay, let's bring our paper down, and now it's the shot caller's turn to measure between the two marks. So come on down and measure between the two marks. You're measuring between the highest mark, the highest part of the mark, and ignore these middle marks. And ignore these ones. Okay, come on over, shot callers. Go ahead and measure, please. Once you have your measurement, you can go inside and finish steps 3, 4, and 5. Okay, measure between the lowest and the highest mark of your team score. I took the markers, nice job. Once you have your number, go ahead inside and finish up.
Just is that yours? That's yours?